Why is it said that light chasing within is destiny? Beyond the pursuit of light is the unknown. Why can't light escape a black hole? What is at the center of a black hole? On the stage of the vast universe, we are all actors, and the trajectory of our actions, but bound by a mysterious force. This power is the pursuit of light, for ease of understanding. So imagine lighting a candle. The waves of light he emits are like ripples, spread in all directions, forming an expanding ball of light. This ball of light, it's what we call a light cone in three-dimensional space. As long as we are in it, it's almost impossible to escape, because we can't go faster than the speed of light. In this two-dimensional slice of the light cone, what we see is an expanding circle. If we break this circle down needle by needle, stack these needles on top of each other, can build a system that will continue to evolve over time. Enlarged light cone. This light cone expands from the past to the future. And we trace your own time in it. The bevel of the light cone is tilted at a 45-degree angle because no matter how time passes, light is always at a fixed distance. Light years travel through the universe in 1 year. This light cone is the key to understanding the structure of the universe, and in particular, they limit causality. Imagine that, a supernova explosion far from Earth. This event, only when his light cone touches the Earth, we can feel. Before that, about any information about the explosion cannot be transmitted to us, because nothing can travel faster than the speed of light. This causal relationship is limited by the speed of light. But here's the thing. Light cones allow us to deeply understanding the difference between time and space. In space, we are free to move in any direction. You can even turn around or follow a circuit. But in time, all objects are forced, heading in the same direction. From the past to the future, in the long river of time, we can't go back. The light cone allows us to see the difference clearly. In space, we are free to choose any direction. But in time, continuous cones of light force us to move forward forever. We can't go back, because we are trapped within these cones of light. This feature enables us to be strict. The grid defines what we mean by time. In relativity, time is where the light cone is pointing. It's a direction we can't turn back. Is the direction in which all trajectories point, and that's where our future has to be. And space is all tied to time. Collection of straight in other directions, without gravity. Empty regions of the universe. The structure of space-time is straight. Time and space, they form a symmetrical grid of straight lines. All the light cones point in the same direction. We can set a time like this. In this chart, time flows from left to right. But imagine this. If there is a very huge object, so the Earth, if we let an apple fall free, he will be attracted by the gravity of the Earth, fall gradually. But gravity doesn't just affect matter. It also affects light. If the apple, as it falls, emits light bubbles, these light bubbles will also be attracted downward. Near a massive object, the light cones are no longer aligned with each other. They're getting crooked, bent by gravity. Near a massive object, directional bending of the light cone. In other words, time is bent towards the center of the planet. If the apple falls, although he was initially static, that's because his future points downward. Mass distorts the geometry of the universe. Space and time become relative. Their direction depends on our position. This is mass and general relativity. Bigger objects, the more it bends space-time. But imagine this. If you have a very compact, massive object, such an object would generate strong area ratio so that below a certain height, all light cones will point completely downward. If we light a candle in this place, no matter the direction of the light, they're all going to fall towards the center. And this is what we call a black hole. A black hole is a spherical region in the universe, a kind of foam. In regions of space-time push all objects towards the center. If we consider a two-dimensional slice of space, the black hole appears as a static circle and forms cylinders in space-time. The boundary of a black hole is called the world. Above the world, some light can escape, but beneath the world, all the light is captured. To truly understand what a black hole is, it is better to consider two different points of view. One is the view of an astronaut falling into a black hole. The other is the distant observer's point of view. For distant observers, gravity is very weak. The space-time grid around him is flat. For him, time flows from left to right. The world of black holes appears to be static. Draw a straight line from the past to the future. But let's now start from falling in, the astronaut's perspective on a black hole, as he gets closer to the world. Time and space are bending ever more, bent by the presence of a black hole. When he finally reaches the world of black holes, astronauts don't realize. But at this point, time and space tilt at a 45-degree angle. For astronauts, the world is not a horizontal line from the past to the future. It's a diagonal going up at a 45-degree angle. Like the surface of a light cone, although distant observers, you see, the black hole is stationary. But for astronauts around the world, time and space are tilted. So much so that the black hole behaves like a light cone. This explains why there is no escape. As he moves through the world, the concepts of time and space seem to be reversed. Compared to the outside, time now points downward. So this was a direction in space before. The world is no longer a place in space. It's a moment in our past. And the center of a black hole is no longer a point. It will be a world in our future, a fate we cannot avoid. Beneath the world, all objects inevitably fall, because this is their future direction. When a giant star explores, he will give one last ray of light, a final cannon of light attempting to expand, but in space-time bent by the mass of the star. This light cannon seems stationary from the outside. A black hole has formed. It's a light cone held still by the curvature of space-time. If we straighten this graph, we will restore a global time direction from left to right. In this straightening chart, we see clearly the world of the black hole forms a light cone, emerge from a greedy star, can't escape from the inside. Once we cross the world, we are forced to hit the center, a place where the curvature becomes so intense, so that our models don't work anymore. At the center of the black hole is a future world. And finally, if we compress this graph, we get a Penrose diagram. Inside and outside the black hole, they form two distinct regions. Once we cross the world, The entire universe is behind us. In our past, we're never going back. Our only possible future, just fall to the starting point. This is the beginning of the sentence. In pursuit of light is destiny. Beyond the pursuit of light is the unknown. Is it possible to detect beyond the light chase? A simple analogy. You meet a fortune teller who tells you, "You have a bloodbath in 5 minutes." You can't believe it. 5 minutes later, you get a kick. It's bleeding before you believe it. This seems to be beyond the light cone. Predicted beyond the light cone. So is destiny preordained? Is it possible to predict the future? Let's have a good chat when we do the show next time. Forget it. You have a word I love to hear.